Okay, we're doing exactly one outcome today, which is a little more probability. This is the game Yahtzee. Remember Yahtzee where you had the 5 dice and you had to roll them and you were looking for exactly some numbers, like you got to roll and get exactly 3 3s? Well, we're going to look at that a little closer today. In this example, you toss a die and you get to toss it 4 times. And you're going to win that $1,000,000 if you get a 6, but only twice. 6 comes up 3 times, no $1,000,000. So here are your rolls. You could win if you got a 6 here, here, but then you better not get a 6 here or here. You get a 6 here, not here, here, but you can't get one there. Or you can get it here, not here, not here, and on your last roll come through. Not on your first, on your second, on your third, but then not on your fourth. Not on your first, on your second, not on your third, but on your fourth. And then the last possible way is pulling it out in the end, getting a 6 on your last 2 rolls. So you notice there are 6 different ways for this to happen. And then if you figured out the probability of it happening, well, you wanted a 6 to show up twice. Once, twice, and now your other 2 rolls can't be 6s. So there are 5 other numbers on a die that you wanted to show up. You see, each one of these rolls over here contained a 1/6, a 1/6, and then 2 others that were not 6s, so they were 5/6 out of 5/6. So if I canceled and did my math, there's a 25 out of 216 chance of you rolling a die 4 times and getting a 6 exactly twice. So we have a little formula that helps figure that out. Oops, let's cover that up for a second. Here it is. It looks very daunting, but it's not. This NCR, that figures out how many combinations there were. See, on the last problem, there were 6 combinations of you rolling a 6 exactly twice. So the NCR is going to figure that part out for us. Then, remember the losing probability? That was the 5 out of 6. That was when you didn't want it to be a 6. And the winning probability, well, that was 1/6. So if we looked at the example from the first page, this is what it would look like. See, we got to roll the die 4 times, and we were looking for exactly 2 6s. 4C2 gets us that 6. Then we wanted 2 non-6s, 5 out of 6. And then we wanted 2 6s. That's 1 out of 6. Do the math, and we get the same answer. Let's try a couple. This time we've got a spinner right here. And I want the probability of exactly 3 odd numbers, and I get 4 spins of the wheel. So I'll win my $1,000,000 if I spin this thing 4 times, but odd numbers only show up 3 times. So the first thing I do is I like to get my probability straight. So since they want me to get odd numbers, that's my win, so to speak. My winning probability, in this case, is 2 out of 3. And thus my losing probability, I don't even have to look at the spinner because it's even odd, my losing probability would be 1 out of 3. All right, so let's write this formula. Let's bring this down here so I can see it. Well, I get to spin 4 times. I'm choosing 3. I got to look for exactly 3, so that goes down here. My losing probability, 1/3. My winning probability, 2/3. Well, how many times did I want to win? I wanted to win 3 times, so my 3 goes there. And then this, I want it to be 1, because I get 4 spins, and 1 plus 3 gets me 4. Now I can just do the math. That's 1/3. 2/3 to the third power is 8 over 27. And 4C3, if I bring out my calculator, is, right there I have it, 4. Do the math. 32 out of 81. All right, now I'm going to flip a coin. And again, I look, how many times do I get to flip it? 10. What is the probability falls tails? 6 times. So I just figure out my probability. Tails is what I want. So that's my winning probability. And that's 1/2. Heads is what I don't want. So that's my losing probability. And that's 1/2. Put it all together. 10 flips of the coin. See, I want it 6 times. My losing probability is 1/2. And I want that to show up 4 times because I want my tails, which is my winning probability, to show up 6 times. Now over here, I have all this math worked out. 10C6 is 210, 1/2 to the 4th power is 1/16, and 1/2 to the 6th power is 1 over 64. I did my cross canceling, and there's my answer. 105 over 512. Now remember, it's probability, so you don't have to cancel if you don't want to. I want to take this time to introduce you to Pascal's triangle. Back in my day, when we didn't have a calculator, we had to figure out our NCRs by using Pascal's triangle. So the top of their triangle, his triangle, starts like this. 0, C, 0. The next row represents 1, C, 0, and 1, C, 1. The next row, 2, C, 0, 2, C, 1, and 2, C, 2. And running out of room here, but this would have been 3, C, 0, 3, C, 1, 3, C, 2, and 3, C, 3. Now, what did this all mean? This was choosing. Let me see. Let's get this up here. All right, see, these are objects. And let's look at this row right here. Let's look at this row. This is saying I have 2 objects. Here they are. How many ways can I choose none of these objects? 1 way. I don't take any of them. Next, it's saying, given 2 objects, how many ways can I choose just one of them? Well, I can choose either this one or this one. So there were 2 ways I could choose one object. Now, given 2 objects, how many ways can I choose 2 of them? There's only 1 way. I take both of them. So that's what those combinations are doing. They're showing you how many ways you can choose objects at a certain time. Now, what is Pascal's triangle? How would have I gotten to the next one? It's really easy. Some of you may have already seen it. The next row would have been 1, 5, 10, 10, 5, 1. That's right, I just add. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. Bump out the ones. If I went back to this problem, well, no, that one's too big. Let's go back to this one. 4C3. Now when I was doing this, 4C3, I would have to go to the row that represents the 4s. Remember, this row represents zeros. 1, 2, 3, 4. 4C3. 0, 1, 2, 3. And gets me 4. Bye.